Welcome to Matematika. Today we're going to do the second lesson in Unit 1, which is the rates of change. In AP Precalculus, the rate of change is the ratio of change in output values to the change in the input values over a given interval. And it's calculated by finding the slope of the line that connects 2 points on the graph. If we try to remember, or basing on the definition itself, it is the change in output values over the change in the input values. Okay, input. Or when we were in algebra 1 or 2, you always have the change in y over the change in x. Remember that the output is the dependent and the input is the independent. Okay, so the independent is the x and the dependent is the y. That's why we have the change in x over the change in y over the change in x. So that is y sub 2 minus y sub 1 over x sub 2 minus x sub 1, and that is the slope of the line. Okay? Now, for example, you're given a graph here. You're asked to find the average rate of change between 1, 2, or the point 1, 2, and 3, 4. So we'll try to find that point here in the graph. Okay, it's a 1 in x and 2 in y. So I'm going to, do a line from x to the curve, and then from the graph towards the y-axis. Okay, so that is the location of the point is somewhere here. That's 1, 2. Okay, and 3, 4. 3 in x and 4 in y. So if we do this, we could have here and towards the y-axis from the curve to the y-axis. There. So this point right here is 3, 4. And this is, our dependent value, which is the y, and this is the independent, the x. Okay. Find the average rate of change. So usually when we do that, just simple as doing as, let's say this is our x1, y1, and this is x2, y sub 2. So you could simply go straight by doing that, since the points can be seen in the graph. y2 minus y1, x sub 2 minus x sub 1. So you have, 4 minus 2, then your x sub 2 is 3 minus 1. So you have 2 over 2, which is equals to 1. All right. So you could say that the average rate of change between 1, 1 and 2, 3 and 4 is equals to 1. Or simply we could say the slope. If we connect a line, let's say I will try to connect. I will get the ruler right here. If we connect the points, okay, we could say that, let's say this is the line right there. We could say that the slope of the line, this is the slope of the line, is equals to 1. And you can see that it's positive. Okay, basing on our, lesson 1, we could tell right away the direction of the line, that is from bottom left towards, climbing up towards the top right. So it is positive. All right. That is the simplest way when we encounter problems like this in finding the slope. But you may ask, how about if I interchange? I made the 3, 4 and 1, 2 as x1, y1, and this is x sub 2, y sub 2. Do I still get the same slope? Let's check. And I said yes. Whatever pair or coordinates that you're using as x1 and y1, x2 and y2, the same result will come out. So if we're going to do this, for example, 2 minus 4, then you have 1 minus 3. So you have negative 2 over negative 2, you still come out with 1. Still the same answer that you're going to have. Okay, let's try this. In a table, so usually you are given a table, right? I remember this in my algebra 2, I think. What is the rate of change in the intervals from 10 to 19 seconds? So you have a table of t as time in seconds and d of t as distance in meters. So the time here is our independent. Okay, you could say when you have the dependent, because it always written as in terms of a function. All right, so 10, where is 10? Somewhere here, to 19. So if I get the, when the time is 10, I have the distance traveled in meters as 80. When the time is 19, I have it distance as 43. So simply by doing, the chains in x, the chains in y over the chains in x. So I could make this as x1, y1, x2, y2. So I have the chains as y2 minus y1 over x sub 2 minus x sub 1. And that is y sub 2 is 43 minus y sub 1, 80, over x sub 2 is 19 minus x sub 1 is 10. So 43 minus 80, that's negative 37. 19 minus 10, that's 9. So when you divide, it will be equals to negative 4.11. Be sure to include the unit. So when your distance is in terms of meters per second, okay, we say per is for every seconds that you do, you come up with a certain distance. All right. So that is if you are given a table. How about, let's do the average. Usually, if we are given a graph, okay, so as we said that the average rate of change of a function is between 2 points and can be found by drawing, you draw a straight line between the 2 points and you find the slope, okay? So let's say, for example, we can see in our line here that our first point, when it's negative 1 and we have a 2, right? So this coordinate, when it's negative 1, we have the value of the output is 4. When it's 2, we have the output as 1. Okay. By looking at the line, when we connect these 2 points right here, we could tell right away that this is decreasing, because the line is from top left going down to the right. Okay, so it's decreasing, and I will emphasize it as we find the slope. Okay, so in other words, I could make this as x1 y1, and this will be x2 y2. If I will be using like the interval, there are two ways in writing, the interval. Like you say from negative 1, there is no indication, so we'll just use an x here, from negative 1 to positive 2. Or you could say the interval, using the interval symbol, negative 1 and 2. Right? So either, if you are given this kind of type of intervals in the problem, don't be confused or be alarmed, because it is still asking the same thing. Okay, asking you to find the slope of the line. All right, so in this case we can have I can have y sub 2 minus y sub 1, that is over x sub 2 minus x sub 1. Simple as that. Okay. Y sub 2 is 1 minus y sub 1 is 4. X sub 2 is 2 minus x sub 1 is negative 1. Okay. So that would be negative 3. 2 plus 1, that will become positive 3. So we have the change, the average rate of change is negative 1. So you could say the average rate of change of the function, since you are given the function, it's here in the function, like on the graph, you're given the graph there, over the interval. So what interval could that be? So we could use the symbol interval of -1, 2 is equals to -1. All right. By writing this, because sometimes you are asked in the problem, how would you explain or how would you justify your answer? You don't stop. When you answer, do not stop. You have to finish what is asked in the question, because that will give you the full credit of the question asked. So what does it means? Okay, I put an asterisk here. So meaning that on average, say average, like the y variable. So what are our y variable there? We have 1 and 4. It changes. How does it change? By -1. Since there is no unit, you just write units. For every, since we have to consider the independent values, change in x. Every unit or every time there is a change in x variable. All right. Be sure you're going to give out that explanation if you are asked to, justify your answer. Okay. There are two types of rates of change. It can be a positive rate of change or it can be a negative rate of change. So when we can say that the rate of change is positive, that indicates the quantity, one quantity increases or decreases and the other quantity also or does the same thing. So whether if I like to do it in a graph, I could say the x, the dependent, increases as well. The independent increases as well as the independent. So our graph would tend to go that way. Both are increasing. In, let's say, for example, as the years increase, what happen as the years increase? So what do we usually say? High school students. High school, let's say, the high school student body increases. Also increase. That usually happen. Like as the years go on, the students also increases. So that means if we try to look at this, increase. So both quantity increases. Okay? So both variable increasing as the rate of change is positive. Because both are increasing. Okay? Its negative rate of change indicates that one quantity increase and the other one decrease, or it's either way around. So if we try to make a sketch, let's say our independent increase, what do you think is our dependent here? Our dependent is decreased, so our graph tends to go down. So both one variable is increasing and the other one is decreasing. And that is an example of a negative, okay, negative rate of change. The third one that we are concerned on this lesson is that the rate of change at a point, okay, at a point. And that is what we call the instantaneous rate of change. So if you are given this term, instantaneous rate of change, or the rate of change at a single point, can be approximated by finding the slope of the line just touches the graph. Okay, the line that touches the graph is what we call the tangent line. Okay, so how are we going to do that? You make an estimation. You estimate the rate of change by looking at the average rate of change over very small intervals around that point. Okay, so let's look at this graph on the left side right here. We can see a dashed line. All right. So, for example, one point is right here. This is point A, let's say. And this is point B. So, point B, if we try to draw a line and connect, okay, we have a certain value or the average rate of change. But what happened? We are trying to estimate the rate of change as to the average rate of change would be very small interval around that point. So we try to move the B somewhere here. As we move the B, this point, we are moving closer. I move it more closer and closer. The more, the rate of change can be estimated, or the slope, the point gets smaller and closer to the point of the slope of the line. All right? Well, look at that. I will be giving you a problem that will tend to let you understand. So the more it is closer interval around the point, so you're approximating the slope of the line. Just touches the graph of that point. Very close until point B is somewhere at this close. Right there. With a small, very small intervals. So, in other words, what have you noticed the interval there? So, as the interval around that point, so let's say the point I'm talking about is point A. Around point A, get a smaller and closer to the point, the slope of the line, to the point that is the slope of the line. All right, or we call that closer by using, slope of the tangent line. Tangent line is the line that, touches the graph. So from at point A, we draw this line right here. Okay, I think we have done that drawing a line that touches the graph using the tangent line. Okay, let's have examples. Let's do an example. State whether the situation represents the positive or negative rate of change. Actually, if you are looking at this is a very, very simple way of looking at whether it's positive or negative. When both are, increasing, you would say it is positive. Okay? And one decrease, the other one increase, then it's negative. So in number 1, as the amount of water Mr. Hines drinks increases, so that's the word that indicates the more frequent he went to the restroom. So we don't see the word increase, but we see the word more. That means when it's more, it increase. So that means both are increasing. This is a positive rate of change. As the number of times, this is number 2, as the number of times he withdraw money from the bank increases, so the more he withdraw money at the bank, what happened to his savings? Fewer, meaning the money decreases. Fewer savings is left. That means one increase, one decrease. This is a negative, okay, rate of change. Okay, simple. Find the rate of change of the given interval. The function h of t equals 3t minus t squared over the interval of 2 to 5. Okay, so what we're going to do is find the h of 2, the output, the result when you put in or input 2 in the function. Okay, 3 times 2, that's 6. 2 to the second power, that's 4. 6 minus 4, that is 2. When it's h of 5, so 3 times 5 minus the quantity of 5 squared, 15 minus 25, that is negative 10. So by using I think I forgot something here. Let me go back here. I would like to remind you something. I messed out. The formula for that. If we have A and B as the point right here, A and B, so you can have the function of B minus the function of A over B minus A. So you're going to indicate that in the problem, and that would become what is our change in y here over the change in x. Sorry for that, for going back. So A and B is our x variable or x values of the function, and change in y, that is the vertical change, because I'm going to use this in that problem. And change in x is the horizontal change. Okay? All right. Sorry. So, in other words, I could use the h of 5 and minus the h of 2 over b, which is 5 minus 2, because this will be a and this will be b. So going back to f of b minus the function of a over b minus a, to that formula. So the function of b, our b is 5. So this is the function of b, and this is the function of a. Okay, so what is the h of 5 is negative 10. And then minus 2. That's the h of 2. So 5 minus 2, that is equals to 3. So 10 minus 2, that is negative 12 over 3, that is equals to negative 4. Okay, that is the rate of change in the given interval from 2 to 5. BW is equals to, the function of BW is equals to W plus 2 to the power of W over the interval of negative 1, 2. So you could use the B. I could start with the B of negative 1. So substitute it to the function itself. So what would that be? That is negative 1 plus 2 to the power of negative 1. Take note, we're going to use our knowledge here of a negative exponent. We did a prerequisite review of, laws of exponent. So we have a negative 1. So how will we change our 2 to the power of negative 1? By getting the reciprocal and making it into a positive. So this will become negative 1 plus positive 1/2. That will become a negative 1/2. Right? When the b is b of 2, that will become 2 plus 2 to the second power. That would be 2. 2 to the second is 4. So that is equals to 6. So using the formula of the function, so this is the function of b. This is the function of a. So that means using the f function of b minus function of a over b minus a. So this is a, this is b. So let's substitute. That would be 6 minus a negative 1/2 over 2 minus a negative 1. So that will become 6 plus 1/2 over 2 negative 1, that's 3. So I could say change the 6, that's 6 plus 1/2, that would become 6.5 divided by 3. I could have 2.1666. I could round that off to 2.167. And this is the rate of change with the given interval of negative 1, 2. Okay, let's have a problem. The water level of a water tank as it drains is given by the function Wt measured in meters, T time T is measured in minutes. This is represented by the following table. So we have a table for minutes, 0 to 6, and table for the function of t from 12 to 6. All right. Question A. How fast is the water tank draining on the average over the 6-minute interval? Okay? 6-minute interval. All right, so maybe I could write the formula down with that is a function of b minus the function of a over b minus a. I want to find what is my a and what is my b. So it says 6. What would that be? From starting here and start on over here. All right. This is time in minutes. This is the independent. And this is the dependent. So 6 is 0 to 6. That means my A is 0 and my B is 6. This is my A and this is the B. And what would be the output? When it's A, it's 12. So this would be f of A and this is the f of B. Okay. So we are using W's of T. That means the WB is 6 minus the W of A is a function of A is 12. All right. Over B is 6 minus A, which is 0. So we have a negative 6 over 6. That's equals to negative 1. Oh, I should have written it here. Sorry, could I change this? Because I will be using that space for, I'm going to write it here. Minus W. I'm using the space for the second question. So this will be 6 minus 12. 6 minus 0. Negative 6 over 6. That's negative 1. I'm going to erase this portion right here. I will be using, that space. So I could say that A is 0 and B is 6 for that question. And the function of A is 12. The function of B is 6. Okay, so by looking at this from 12 to 6, you could say right away that it's decreasing. So you expect that your rate of change is, a negative. So you could say that the rate of change is negative 1. What does it mean? So it means on average, so regularly the water level decreasing by 1 meters. The water level is decreasing by 1 meters. By what? Each minute. During the interval. So what is this? This is -1 meters per minute. That's how you get your average of change for letter A. For letter B, estimate the rate of which the water level is changing at t equals 3. Remember, we are trying to get the rate of change at a point. All right, so what did I say? I presented to you the graph that as we keep on moving, okay, I'll go back to that graph right here. This is right here. We are trying to get the instantaneous rate of change in that problem. So as we keep on moving the point closer to that given point, wherein we could use the tangent line or getting the slope of the tangent line, okay, as it touches the graph. You can estimate by using the calculator. It's easy because all you have to do is use the calculator. How about if during the test you are not allowed to use the calculator? No calculator use, so you cannot use that way in getting, the instantaneous rate of change at a certain point. So let's do this. How are we gonna do? Okay, first of all, let's locate 3. 3 is here, right? 3 is right here. So to estimate the rate of change at t equals 3, we will find the average rate of change over the small intervals around t equals 3. So let's try to calculate the average rate of change to some values approaching t equals 3. Approaching. So we are trying to get the values that are approaching when t is equals to 3. Okay? So let's say I will use the average rate of change when t is 0, t is 1, t is 2, between 2 and 3, between 0 and 1, between 1 and 2, between 2 and 3. Okay. Give me a short pause. So, let's say between t is 0 and t is 1. So, let's say what happened to it. 0 and 1. So, that means our A is 0, our B is 1. So, the function of A is 12. The function of B is 11.5. All right. So let's get the f of B is 11.5. F of A is 12. B is 1 minus A 0. So when we try to simplify that to 11.5 minus 12, that is, you have 0.5. That is negative over 1. So you have a negative 0.5. that is, the rate of change. I'm going to use this. The rate of change from 0 to 1. So we have a negative 0.5. Okay, let's do between 1, when t is 1 and t is 2. Okay, that's between 2 and 1. All right, let's do this. So our t is of 1 now. So our a would be 1, b would be 2. So f of a would be 11.5. F of b would be 10.8. Okay, so in this case, we have 10.8 minus 11.5 over 2 minus 1. 10.8 minus 11.5, we have a negative 0.7 over 1. So we have a negative 0.7. So our rate of change here is negative 0.7. Let's try. We are moving closer to the point 3. All right, this here, that point. So if I use between t is 2 and t 3, okay? So what would be my a would be 2, and then b is 3. So my f of a, when it's 2, it's 10.8. And f of b, when it's 3, that's 9.9. All right, so I'm going to use it here. So that would become like 9.9 minus 10.8. Then I have 3 minus 2. So I have a negative 0.9. Let's see, I'm using my calculator. How much would that be? 10.8, right? Give me a minute. So I have 0.9. All right. A negative 0.9. So what have you observed? The more it's closer to the point, it becomes approximately as negative 1. Okay? So I could say, I could have it here. Sorry, I have a bigger space here. So I could make my statement now. The average rate of change how does we see as we are approaching? So appear to be approaching. 0.9 is, closer to negative 1 as the value of x approaches 3. You can see I showed it as the value of x. Our value of x is 0, 1, 2. As the value of x approaches the point 3, that is the question asked in the problem, I showed you what happened to the rate of change as it goes closer to 3. And we come up with a negative 0.9, and that is approaching to a negative 1. All right, when you round that off. So we could say, so what can we say? What is our approximate value? It's look ugly. So the instantaneous, we're looking for the instantaneous rate of change at x equals 3 is negative 1. You may ask, is there in a way that I could not do all this stuff by doing it in a simple way? Yes, of course. You can just subtract a number that is as certain as 0.001. All right, I'm gonna show it. I'm gonna show you a problem by not doing like this, but this explains how we could approach the problem. And you can do a lot of explanation when you are trying to solve. You can either check, you try to check from here to here. Let's say from 6 to 5, going that way, then 5 to 4, then 4 to 5. What is the rate of change from the 2 points approaching to positive 3? And check if you still come out with a negative 1 as the rate of change or your instantaneous change. Okay? And I'm quietly sure you still get, as you move closer, 4 to 3, you still come up with a negative 0.9. And you approximate it as to a negative 1. Okay? All right. In the next video, I'm going to do problems and solutions of the rate of change. Some more setup, how it looks like. Probably how it looks like in the test. All right. So before that, let me say this. If I can do it, so can you. So please don't forget to like and subscribe my video. See you.